Good afternoon, and thanks for the time and the help to put this on. So my background was with 36 years with Dow developing materials and ended up being a vice president along with my partner, Clive Bosniak, had about 25 years as a material scientist. And what we did in our time there is we tremendously changed the world of polyethylene with some technology and expanded the boundaries of what you could do with it. And at the same time, we had our central research working away at nanomaterials to see if we could do that again, because one of the major problems with large volume materials is people have pretty much optimized it. How can you change the system so you can lower your cost? And so what we came up with, next slide, is after we spectacularly failed in Dow, we retired and decided to do it ourselves and formed Molecular Rebar. And what we did is we buy carbon nanotubes, which aren't nanotubes. They're really bundles of nanotubes, which are micron sized, and they don't really work very well for what we needed to do. So we learned how to make them into the individual tubes. So we really have a source of individual nanotubes about 800, 900 nanometers long and 14 nanometers in diameter. And we put them in materials wherever we can mix them. And for example, you can see those little strands on that lead paste. Those are actual individual tubes. And when you do that, you start totally changing the boundaries of materials. So let's take a couple examples. First being, if you turn the slide, is well, popular one is lithium batteries. And these actually are designed more for electric vehicles. And what our capability is if we put our material in with silicon into a graphite anode, we can increase the energy density 20 to 40%. So same volume, 20 to 40% more energy, pretty straightforward how valuable that is. If we put our material on the cathode side, we can have it charged 4 or 5 times faster. So rather than charging your battery in an hour, 10, 12 minutes. And those were not possible until you had these individual tubes, which we call molecular rebar. So we have over 10 customers in qualification trials. One actually is launching product as we speak. So we can actually go out and buy these kinds of batteries. And incidentally, we put this in lead batteries. We'll sell about $6 million worth in lead batteries where we extend a lifetime. Another example, if you turn the slide, is tires. Everybody knows about tires. And where we were working with Goodyear on is mining tires. And these tires are 4 meters tall. So you can imagine how big they are. And the big issue there is how can you resist getting cut and chipped so you have a flat tire at the bottom of a mine. Tremendous cost for the tire, but even more because your mine is down. And what we did here, these materials have been optimized for 50 years. And in the blue, the spider diagram, this is a balanced property. And if you try to get an improvement in one, you always lose something in another. And if you notice the green, which is these materials added with just 1.5% of our material, you dramatically improve cut and chip. And that's really interesting to obviously mining tires or mining oil parts, tires, and so on. And so we actually have commercial sales in blowout preventers. The next target we're going to do is change how you do tires for electric vehicles. And we basically can expand this some more and have improved cut and chip, improved fuel economy, lower weight, higher toughness. And we're aiming that for electric vehicles who have a much more difficult design criteria than the current tires. And you can see in the as made, there's chunks in there. And then the discrete, you can see those little tubes, and it's the whole secret is the individual tubes dispersed. Next slide.
30-second warning.
So we have a huge range of applications, as you can see, that we're working on. In the next slide, for example, here's coatings. Coatings that last 3 times longer. Next slide. And one that's kind of an outlier, we can do chemotherapy with no side effects. And a long way we got here, but you can see the utility tubes is very broad. Next slide. So where we're at is we've begun sales. We need investment to build capacity, to add development people. We're really moving out of the research phase. We also need to keep our portfolio of over 100 patents continuing to expand. So we protect our competitive advantage is we have utility patents to protect all the composition of matter that we have for this. And with that, we'd again like to thank you for the time. We are starting to try to start work with the military, and we too have an AFWorks project. We're trying to focus in on tires because pilots told us they need better tires. Thanks. Any questions?
So Kurt, I noticed most of those depictions I saw there, the fibers, the nanotubes are more or less kind of randomly oriented. Are you able to orient them all to do sort of anisotropic stuff, or is it pretty much all isotropic?
We can orient them. For the applications we've chosen to work on, isn't needed.
Right.
But if you talk to my partner, he'd get all excited because he loves to do it. What you can do is you can put them through dyes and orient them that way. You can orient them magnetically. We just need an application to do that. The applications are infinite. Our issue is stay focused. And so we take those 4. That's a good question.
Right. Thanks for that.